This week on the show, we have FreeBSD 12.0 finally here, a partly clouded IPsec VPN, KLEAK with NetBSD, how to create a Synth repo for you, and a GhostBSD author interview in this week's episode of BSD Now. BSD Now, episode 276, ho ho ho, 12.0, recorded on the 12th of December 2018. Hello, I'm your host, Benedict Reuschling.
And I'm Santa Claus. I mean, Alan Jude.
Yes, you might have guessed what we have in headlines this week. Finally, after a long wait, FreeBSD 12.0 is available. Woo!
Yes,
and of course,
lots of interesting stuff going on here.
Yeah, we should cover at least a little bit.
Interesting changes. In particular, in userland, the group write permissions to /dev/ACPI have been changed so that anybody in the operator group can invoke ACPI conf and so on to be able to suspend the system. Similar to if you're in the operator group, you'll notice in your desktop environment, you'll have the ability to shut the system down. Now, you'll be able to force a suspend that way. So that's very nice. Also, the default devfs rules have been modified to allow mount FuseFS from within the jail so that you can mount USB sticks and so on. Some tightening of the restrictions on new syslog so that it will not try to rotate files that are set UID or are executable log files, because we don't want it to be moving files out of the way on yours. You don't want somebody to be tricking the system into breaking itself or something. There's now a with reproducible build flag that is enabled by default. So if you compile FreeBSD 12 or later, you'll notice that your uname message doesn't have the source code revision number and the date and the path of where you built the kernel and so on. So that if you build just 12.0.0 basically, from the source code, you should end up with exactly the same binary as what's on the CD. You can set that knob in source.conf off if you want the development information back so that your kernel will be unique to you and you'll be able to tell which one it is.
Yep.
Other interesting updates. dtrace has been updated and now has support for if and else statements. So thanks to the Open dtrace project for that. The legacy version of GDB, the debugger, has been moved to user libexec, so it won't be in your path. That's only currently used by crash info to do the little summary after when the system goes back up after a crash. If you want to debug stuff, you're highly recommended that you install the newer GDB from ports. It does a much better job of getting the backtrace out of things and works very well for like the KGDB version for debugging crash dumps and so on. One that people have been working on for a while is the setfacl, the ACL manager tool, can now do recursive operations with the capital R directory, or capital R flag, so you can, do a whole directory and all its subdirectories and files with the same ACL instead of having to do it kind of slower. One other people asked for is the Geli utility has been updated to provide support for initializing multiple providers at once with the same passphrase or key. So that, if you have a 2-drive mirror or something similar to that, you can initialize all of them with the same key so you don't have a separate password for each drive or something. Quite useful for machines where you have multiple drives. One that's people might like, the DD utility has added the status equals progress option, which prints out the status of its operations on a single line once per second, so that you don't have to sit there pressing Control T all the time.
What's happening? Why is it not moving? Yeah.
A big one that I'm proud of is BECTL, the boot environment control tool, has been imported in part of the base system now. Similar to BEADM, it's designed to have basically exactly the same command line stuff, but but has a couple additional features and will grow over time, but it's now built into the system. It's not something you have to install. It is always part of the system. It's also a C program and a library that uses libzfs instead of being a shell script. So it's a bit faster and easier for you to use the library yourself in, say, an appliance, or if you want to make a graphical version of BECTL.
Yeah, you had some involvement in that utility.
Right. So I was the mentor for the Google Summer of Code project that wrote most of the code. And then I helped. So that was Kyle Knettinger, who I brought to the Cambridge Dev Summit in 2017. But once he went back to school, finished, and started working, he didn't really have any time to work on it. But thankfully, Kyle Evans managed to pick it up earlier this year and get it finished in time for 12. So big thanks to Kyle and Kyle.
Yep. Cool.
And Kyle Knissel did nothing, and he's no help at all.
There we go.
Lots of other interesting bits. In particular, the ACPI system has been updated to implement the device object types for ACPI 6.0, which was required on some newer Dell PowerEdge servers and AMD EPYC systems.
Excellent.
The AMD temp driver has been updated to support Ryzen and Ryzen 2, including the 2990WX CPU. In the kernel, some big changes. vimage is on by default. So you have vimage jails are enabled by default now. So you don't have to compile a custom kernel to have a network stack in each jail if you create that type of jail. So that's a big win for a lot of people. The crash dump utility, dumpon, has been updated to support compressed crash dumps. So as it's going to write the crash dump out to disk, it can gzip or zstandard compress it as it goes to disk, making the crash dump take less space, which is probably a pretty big win if you have a lot of RAM and don't want to have that much swap. The NUMA option has also been enabled by default on AMD 64 generic and minimal kernel configs. So there's that. I don't think that's actually new, that one there. Anyway, a bunch of deprecated drivers have been removed. IXGB, NXGE, and VXGE. These were very, very early 10 gigabit NICs that were like PCI X. So like before PCI Express, that kind of PCI. So it's unlikely you had any of them, or if you did, you didn't want to use them anyway.
Yep. And there's a rename?
Yes. There's, if you want to get information from your RAM, it's now called JDEC_DIMM, which makes sense because that's where your memory modules are.
Yep.
Other big one, the DRM graphics that provide modern graphics support. The version in base has been deprecated and been removed in 13, but you can get the ports now that'll be updated more often. So all the good stuff there. We'll have more on that in a later story, actually. For storage, a bunch of interesting things. UFS file system have been updated to support check hashes for cylinder group maps. So that's available for UFS 2. And UFS file system has been updated to consolidate trim commands. So instead of trimming individual sectors, it will do ranges. So this will result in fewer trim requests being sent to the drive at once, which will vastly improve performance. The trim consolidation support is enabled by default, but can be disabled by setting vfs.ffs.doTrimCons to 0. So then it won't consolidate. Big news on the NFS front. NFS 4.1 is available, so that offers the pNFS server support in FreeBSD. So you can actually set up the pNFS so that you can have multiple NFS servers and the clients will load balance across them, and so on. It's quite interesting. Couple of changes to ZFS. They added extra tunables for the prefetch. So the regular prefetch and the prescient prefetch have a minimum time in milliseconds setting. So that if something is prefetched, it will be kept in the cache for at least that long, so that it won't get pruned from the cache before you actually get around to using it. This can improve the performance of Scrub by quite a bit, because you prefetch the thing and you have to make sure you actually keep it in the cache long enough that you get around to using it, instead of having to go get it again after you prefetched it but threw it away. Some stuff that was, I guess, missed in the release notes. FreeBSD 12 now supports the SpaceMap v2 pool feature. This means that it can optionally use 2 bytes instead of 1 at the beginning of a spacemap to encode the size, which allows supporting larger spacemaps. So with drives getting larger and with new spacemaps where you might actually cover the entire drive with one spacemap for the device removal stuff, it makes a big difference. It's a good performance improvement there. The large dnode feature was imported. This means that if you created a pool with ZFS on Linux 0.7 and it had that feature, you previously weren't able to import that on FreeBSD, but now with FreeBSD 12, you'll be able to import those pools because we have that feature. And 12 also includes a bunch of bug fixes that Alexander Moten and I tracked down for the device removal feature, where you can remove a VDEV, like a non-redundant disk, or a complete mirror can be removed from a pool, which is a new feature. There were a couple places where interactions with code in FreeBSD, specifically the trim feature that FreeBSD has in ZFS that hasn't made it to other ZFS implementations yet, there was some conflicts in the assumptions there, and it would cause a couple of crashes, but we managed to fix all of those, so that feature will work better in 12 as well. And lastly, there was a bug on FreeBSD 11.2 where under certain circumstances where you were creating and destroying files very quickly, the sync operation could cause a process to hang. I know some people at EuroBSDCon approached me about this, and I helped track it down and get it fixed in head, but that is trickled out as part of 12.0, and we expect to have a patch for an errata so that you can FreeBSD update a binary patch for it for 11.2 sometime next week. So that's available in 12 as well.
Excellent.
All right. Other big change, the bootloader. The default scripting language for the bootloader changed from Forth to Lua, so it's now much easier to write customizations of the menu and the logic there. You can still use the fourth one, so if you've already customized the fourth one and done all that work, you can continue to use that. But if you're doing it fresh, you can use Lua and kind of avoid a lot of the pain that is Forth. Other big one is thanks to Ian Lepore, the loader has been updated to support Geli for all architectures and all disk-like devices. So the Geli boot support I did originally for AMD 64 and i386 has been extended so it works on ARM and other devices as well. So with that, you will be able to have encrypted disks on your little ARM boards or on your ARM64 servers like a ThunderX or a Overdrive.
Oh, yeah. Or your little laptop that's powered by ARM.
Oh, yes. My Pinebook could do it too, yeah. Although that one actually I think uses the U-boot, so might be harder. Anyway. And thanks to Mark Johnson and some other people, the loader now has support for updating the microcode of your processor. So we can do that before the kernel starts, so that if that microcode introduces new instructions or whatever for the exploit mitigation stuff, that the kernel sees those when it originally scans the processor. Whereas, if you do the regular way of updating microcode once the system's running, that those features weren't available when the kernel queried the CPU.
Okay.
So the advantage to doing this rather than the BIOS update is that you can decide to turn it off and reboot, and you'll go back to the standard microcode, which can be very helpful when the microcode is kind of new.
Very nice.
Yep. Some updates to PF2. The PF packet filter can now be used within a jail using the VNet system, so you can have a separate instance of PF in each jail if they're VMH jails.
Firewalling off, yeah.
Yep. And PF has been updated to use RM lock instead of RW lock, resulting in a significant performance improvement. So if you're using 12, PF will be faster.
Excellent. That's what people are looking for.
Yep. Plus tons and tons and tons of other changes. But it's all good stuff. And it's time to start upgrading to 12.
Oh, yeah. And yeah, again, read the full release notes as well as the errata notices in case we discover something
I don't think there are any erratas yet, but they might be in the future, yes.
Yeah. And so a big thanks to the entire release engineering team and all the developers involved in the release. It's much appreciated, your work. And yeah, we look forward to users' feedback and them trying it out over the holidays maybe. And yeah, see what they like. And yeah, look forward to it. Okay, but we don't also just cover FreeBSD. We also have something about, well, actually, Abandon Linux, it's called. Move to FreeBSD or Illumos. That's a blog post over at admin by accident. And goes like the following. If you use GNU/Linux and you are only on open source, you may be doing it wrong. Here's why. Is your company based on open source-based software only? Do you have a bunch of developers hitting some kind of server you have installed for them to do their thing? Being it for economical reasons, remember to donate. Being it for philosophical ones, you may have skipped good alternatives, the BSDs and Illumos. So I bet you are running some sort of Debian, OpenSUSE, or CentOS. It's very discouraging having entered into the IT field recently and discover many of the people you meet do not even recognize the name BSD. Naming Solaris seems like naming the evil itself. The problem being many do not know why. They can't point anything specific other than it's fading out. This has recently shown strong when Oracle officials have stated developers or development for new features has ceased and almost 90% of developers for Solaris have been laid off. AIX seems alien to almost everybody unless you have a white beard. No, we don't. And all of this
not
is
that gray.
not Yep. And so here's why. You're certainly missing two important features that FreeBSD and Illumos derivatives are enjoying. A full virtualization technology, much better and fully developed compared to LXC containers in the Linux world, such as jails or on BSDs or zones in Solaris/Illumos, and the great ZFS file system, which both share. So you have probably heard of a new Linux file system named ButterFS, which, by the way, development has been dropped from the Red Hat side. Trying to emulate ZFS, Oracle started developing ButterFS file system before they acquired Sun, which is the original developer of ZFS, and SUSE joined the effort as well as Red Hat. It is not as well developed as ZFS, and it hasn't been tested in production environments as extensively as the former, which leaves some uncertainty on using it or not. Better not. Red Hat leaves it aside and does add some more, although some organizations have used it in various grades of success. But why is this anyhow interesting for a sysadmin or any organization? Well, FreeBSD, which is a descendant of the Berkeley Unix, and SmartOS based on Illumos, they combine some features that make administration easier, safer, faster, and more reliable. The dream of any system administrator. So to start, the ZFS file system combines the typical file system with a volume manager. It includes protection against corruption, snapshots, and copy-on-write clones, as well as volume manager. Jails is another interesting piece of technology. Linux folks usually associate this as some sort of change root. It isn't. It is somehow inspired by it, but as you may know, you can escape from a change root environment with a blink of an eye. Jails are not called jails casually. The name has a purpose. Contain processes and programs with a defined and totally controlled environment. So jails appeared first in FreeBSD in the year 2000. 2000. That's 18 years ago. Solaris Zones debuted on 2000. Now in 2005, now called containers, are the now proprietary version of those. Yeah, so just think about these years. Okay, so there are some other technologies in Linux such as ButterFS and Docker, but they have some caveats. BetterFS hasn't been fully developed yet and hasn't been proved as much in production environments as ZFS has been. And some problems have arisen recently, although the developers are pushing the envelope. At some time, they will match ZFS capabilities for sure. Docker is growing exponentially, and it's one of the cool technologies of modern times. The caveat is, as before, the development of this technology hasn't been fully developed. Unlike other virtualization technologies, that is not a kernel playing on top of another kernel. This is hitting the same unique kernel which controls and shares the resources. Oh, wait, I skipped something. This is the virtualization at the OS level, meaning the differentiated environments can coexist on a single host. So yeah, the problem comes when you put Docker on top of any other virtualization technologies, such as KVM or Xen. It breaks the purpose of it and has a performance penalty.
Right. And,
so
the idea of a container is to avoid the overhead of a VM, and then Docker goes and says, well, if you want a secure Docker container, just run it in a VM as the only guest. It's like,
yeah,
okay.
Well, yeah, and that's why jails were developed with a security focus foremost, and then the features were added.
Whereas, right. To give you the very short overview, FreeBSD jails were designed to contain PHP scripts, specifically ones that would get compromised constantly and have people trying to take over the machine. So if they are meant to withstand that level of attack, they can handle whatever you can throw at them.
Yeah. Well,
of course,
said. Yeah.
The other advantage of jails is just the isolation. One of the secondary uses of the jails was being able to have multiple different versions of, say, PHP at the same time. You know, we needed an environment to host this version and this version at the same time. You can't really have them installed in the same system very cleanly, but by having jails, you get the advantages of having two separate machines without actually having the overhead of having two separate machines.
Yeah. There's a lot of purposes.
If one of the two environments needs 3/4 of the resources of the system, it can have it. It doesn't have to be, specifically split 50-50 or something. You don't have to reboot the machine to take out two of the CPUs and give them to the other jail. It's just a change you can make while it's running.
Yep. And if it gets hacked, then spin up another one and continue where you left off. Okay, so the author here...
If you're using ZFS, you can just roll back the file system to before and go again.
Exactly, yeah. Did something happen? Yeah. So the author continues with, I have arrived into the IT field with very little knowledge. This is true. But what I see strikes me. Working at a bank has allowed me to see a big production environment that needs the highest of availability and reliability, of course. This is sometimes achieved by brute force, and it's legitimate and adequate. Redundancy has a reason and a purpose, for example, but some other times it feels like killing flies with cannons. More hardware, more virtual machines, more people, more of this, more of that. They can afford it, so they try to maintain the cost low, but at the end of the day, there's a chunky budget to back operations. So what do we do with that? Here comes the reality. You're not a bank, and you need to squeeze your investment as much as possible. By using FreeBSD jails, you can avoid the performance penalty of KVM or Xen virtualization. Do you use VMware or Hyper-V?
Yeah, it's not just about avoiding the performance penalty. It's about kind of similar to ZFS, right? One of the ideas of ZFS is you pull all your storage together and then build file systems on top of that, and they take resources from the pool as they need so that all unused resources are available to a new file system you didn't know you were going to need until now immediately. Whereas with the older style where you had to partition your space into different sizes, you couldn't then easily decide, I need less space on this partition and more space on this partition now. That wasn't an easy thing to do. But with ZFS, each one only takes what it needs, and the rest is left in the pool for somebody else to use, whether it's one of the existing ones or a new one. Basically, with containers, that's what you're doing with the resources of the system, with the RAM and the CPUs and so on. If you create virtual machines, you can have some level of memory ballooning to try to share some of the memory between a bunch of them, but that's complicated and never works as well as it should. But in general, you say, this VM gets this many CPUs and this many gigs of RAM. Whereas with the container, it's like, it just takes what it needs, and every bit of excess is available is on the system and available for the other containers. And it basically gives you that flexibility. Although with RCTL, you can actually put resource constraints on the containers. So you can say that container can only use this much CPU, or you can also use CPU sets and say it can only use these specific cores if you want, or it can use all but the last 2 cores, and then this other jail can use not all the cores except for the first and the last one, and the last one can use all but the first 2. That way, all 3 jails have access to all of your, or almost all of your cores, but each have at least 1 core that's dedicated or specifically available to them and not to their peers, so that everybody can get at least some CPU time some of the time, and so on.
Yeah, that's much more flexible than pre-allocated stuff.
Yeah, because in the end, like if you look at a hypervisor like Beehive, in general, the overhead isn't that high, especially like CPU overhead, there's almost none. With hardware virtualization, we've got rid of the overhead you used to get from virtualization by having to translate instructions and so on. Now, there can still be some penalties for network and disk I/O. Those are not perfect in VMs, but
pretty much
in
any
general,
VMs out there.
The overhead of a VM isn't that bad anymore. So I wouldn't focus so much on the performance advantage of a jail or a container in so much as just the flexibility and the way resource sharing works at a completely different level.
Okay, yeah. So the control and manageability are equal as before, and sometimes easier to administer here. There are 4 ways to operate them, which can be divided in 2 categories: hardcore and human being. For the hardcore use, the FreeBSD handbook and investigate as much as you can. For the human being way, there are 3 options to use: EasyJail, IOCage, and CBSD, which are frameworks or programs, as you may call them, to manage jails. I personally use IOCage, but I have also used EasyJail. So how can you use EasyJail on your benefit, or jails in general? Ever tried to configure some new software and failed miserably? You can have 3 different jails running on the same time with different configurations. Want to try a new configuration in a production piece of hardware without applying it on the final users? You can do that with a small jail while the production environment is on a bigger, chunkier jail. Want to divide the hardware as a replica of the division of the teams that you are working with? Want to sell virtual machines with bare metal performance? Do you want to isolate some piece of critical software or even data in a more controlled environment? Yeah. Do you have different clients and you want to use the same hardware, but you want to avoid them seeing each other at the same time you maintain performance and reliability? Or are you a developer and you have reliable and portable snapshots of your work? Do you want to try new options design with breaking your previous work in a timeless fashion? You can also work on something, clone jail, and apply the new ideas to the project in a matter of seconds. And you can stop there, export the file system snapshot containing all the environment and all your work, and place it in a thumb drive to later import it on a big production system. Want to change that image property, such as network stack interface and IP? This is just 1 command away from you. But what properties can assign to a jail, and how can I manage them, you may be wondering. So hostname, disk quota, the I/O, memory, CPU limits, network isolation, network virtualization, snapshots, and the management of those, migration and root privilege isolation, to name a few. You can also clone them and import and export them between different systems. Some of these things because of ZFS, and IOCage is a Python program to manage jails, and it takes profit from ZFS advantages.
Yeah.
But
so there's lots more to the article if you want to go and read more about it, but it explains why you might consider moving away from Linux.
Yep, has some nice descriptions here and food for thought.
So then we have a partly cloudy IPsec VPN. This article is assuming that readers have at least a basic knowledge of TCP/IP networking and some Unix or Unix-like systems, but not necessarily have used a BSD before. This post will therefore be light on details and other OS specifics, and likely be than you'd normally encounter. For more information, you could check out something like Absolute FreeBSD, 3rd edition by Michael Lucas.
Great
So
book.
overview. The person here is rebuilding their DigitalOcean virtual machine, and they want to set up a Road Warrior Access VPN so they can use their private network resources from anywhere in the world, and a site-to-site VPN so they can extend their home network to their virtual private server. So their home network will be extended to the VPS, and then they'll be able to connect to the VPS from their laptop on the road, and via that have access to their home network even. Plus, they want to host public and private network services and a proxy service to provide a public IP to services hosted at home, giving you a static IP address for your stuff that's running at home.
Yeah.
The last item on the list is because I don't have a public IP address at home. My firewall's external IP address is actually in the reserve space, and the entire apartment building shares a single external address. It's like, that's a little fun. The end state network will provide one OpenBSD droplet running as the firewall, router, and VPN service, and one FreeBSD droplet actually hosting all the network services. So they want to provide access via those droplets to a Nextcloud instance for home, some NAT on the routers, and then because packets going from home to the internet would exit through the apartment building connection and not through the VPN, so it's possible that I could work around that and so on. But they've also set up HA proxy and some other stuff. Since the system includes jails running on the VPS, they've also set up another 1918 internal network and have those reachable from the home network. And once that's done, can access the private address space from anywhere through the VPN on the cloudy router. So they have a little diagram here. At DigitalOcean, they'll have an OpenBSD VM doing the routing and a FreeBSD VM as the jail. And then that will connect to their firewall at home and their FreeNAS, which contains a Nextcloud jail, a Nessus jail, and some other jail.
Oh yeah,
I'll walk through
definitely
that. Installing OpenBSD onto the DigitalOcean droplet, getting it configured, creating the SSL certificates and so on, getting the VPNs sorted out. And then once they have that going, they can configure the firewall. Lots of config examples here, so definitely check it out.
Easy to follow.
Then on their home network, they configure Strong Swan on FreeBSD, and they have that connect out to their DigitalOcean router. Set up the IPsec, and now they'll have a tunnel.
Secure, and no one can listen into it.
Yep. Scrolling a bit. They're going to use OSPF for routing here and get that going. Setting up the proxy so they can forward stuff around. And set up syslogd to log all the HA proxy bits. And then 800-ish lines later, you have a working IPsec tunnel with OSPF routing on both sides and proxy forwarding HTTPS connections to the internal host so that the web service exposed on the public IP goes to the right different jails on the inside, whether that's the Nextcloud or something else.
Okay. Yeah, this is nice, and with all these examples and config files, it should be easy to follow along.
Yep.
So, time for news roundup this week. We discovered KLEAK, Practical Memory Disclosure Detection.
Yes. So this is a paper that came out of NetBSD. Very well done. So they say, modern operating systems such as NetBSD, macOS, and Windows isolate their kernel from the user space programs to increase fault tolerance and to protect against malicious manipulations. user space programs have to call into the kernel to request resources via system calls or IOCTLs. This communication between user space and the kernel space crosses a security boundary. Kernel memory disclosures, also known as kernel information leaks, denote the inadvertent copying of uninitialized data from kernel space to user space. With these, sometimes a programming user space can convince the kernel to give a chunk of memory that was in use in the kernel for something else to userland, which might contain sensitive information. Such disclosed memory may contain cryptographic keys, information about the kernel memory layout, or other forms of secret data. Even though kernel memory disclosures do not allow direct exploitation of a system, they may lay the groundwork for it. So, the authors here, whose names were Thomas Barabosch and Maxime Vallard, introduce KLEAK, a simple approach to dynamically detect kernel information leaks. Simply said, KLEAK utilizes a rudimentary form of taint tracking. It taints kernel memory with marker values, lets the data travel through the kernel, and scans the buffers exchanged between the kernel and the user space for those markers. By using compiler instrumentation and rotating the markers on a regular interval, KLEAK significantly reduces the number of false positives and is able to yield relevant results with very little effort. With their approach, it's practically feasible, as we proved with the implementation of for NetBSD, but a small performance penalty is introduced, but the system remains completely usable. In addition, to implement KLEAK in the NetBSD kernel, we applied our approach to FreeBSD 11.2 as well. In total, they managed to detect 21 previously unknown kernel memory disclosures in NetBSD current and in FreeBSD 11.2. And all of those have been fixed since. As a follow-up, the project's developers manually audited related kernel areas and have identified dozens of other kernel memory disclosures as well. The remainder of this paper is structured as follows. Section 2 discusses the bug class that you might, the different types of bugs you might get from kernel memory disclosure. Section 3 presents KLEAK to dynamically detect instances of those bug classes. And Section 4 discusses the results of applying KLEAK to NetBSD and FreeBSD. And then finally, Section 5 reviews all prior research, and Section 6 is the conclusion. If you're interested in that, check it out. But it's a very cool idea. And I like the fact that they proved that their approach worked beyond just NetBSD by also applying it to another BSD.
Yeah, that's a good verification whether your idea can translate to another system. Okay, speaking of another system here, we have a how-to for you, how to create official Synth repositories for Dragonfly BSD. And they describe how to create an official Synth repo. So with the system environment, that you have to make sure that user/dports is updated and that it contains no cruft, like the git pull or git status, or doing that. Then remove any cruft so that's completely pristine. Make sure your synth is up to date with package upgrade synth. And if you already updated your system, you may have to build synth from scratch from user/user/dport/ports management/synth. Then make sure that etc_make.conf is clean. Update user source to the current master. Make sure that there's no cruft in it, and do a full build world, build kernel, and install world. Then you reboot. And after reboot, before proceeding, running uname-a and make sure you are now on a desired release or development kernel that you want to provide. So then we go to the synth environment. So in user local etc_synth, that contains the synth configuration. It should contain a synth.ini file. You may have to rename that template, and you will have to create or edit a livesystem-make.conf file. So system requirements are hefty. Just linking Chromium alone eats at least 30 gigabytes, for example. Concurrent C++ compiles can eat up to 2 gigabytes per process, and they recommend that at least 100 gigabytes of SSD-based swap space and 300 gigabytes of free space on the file system should be available. Okay, but the synth ini should contain the following parts that we have in the show notes here. Plus, you modify the builders and jobs to suit your system, so don't overload it. But with 128 gigs of RAM, 30/30 or 40/25 works well. And if you have 32 gigs of RAM, then maybe 8/8 or less is a good way to start. So then you put in all those configuration sections that are listed there. And then live system conf should contain one line restricting the licensing to only what is allowed to be built as a binary package. So licenses accepted equals none. And then make sure that no other craft is in user local etc Synth. So you start from a clean environment. And in our example here that you have in /build//synth, tongue twister here, make sure the base directories exist. Otherwise, that will be causing an error. Clean out any craft for a fresh build from scratch, rmrf, the empty build directories, and then run synth everything. They recommend doing this in a screen session or tmux in case you lose your SSH session. It happens, yep. Assuming you're SSH'd into the build machine. And yeah, then synth everything will happily run. And they describe that a full synth build takes over 24 hours to run on a 48-core box and around 12 hours if you run on a 64-core box. With a 4-core or 8-thread box, it will take at least 3 days. There will be times when swap space is heavily used. If you have not run synth before, monitor your memory and swap loads to make sure you have configured the jobs properly. And if you are overloading the system, you may have to Control-C the synth run, if that's still possible, reduce the jobs and start it again. It will pick up where it left off. Okay, and then basically, yeah, you continue the rest of the description. It's not much, but it's a good way to start your own synth repo. Great. So next up, we have a, pseudo interview, let's say. We found this on FreeBSD Bytes, an interview with the founder and maintainer of GhostBSD, Eric Turgeon. And I guess Alan reads the answers and I just read the questions. Is that the way we do it? Okay, so first question goes, thank you, Eric, for taking part of this in this interview. To start off, could you tell us a little bit about yourself, just a bit of background?
Okay, so Eric, not me, is a French-Canadian. He's married to a wonderfully patient woman and has one son, and currently works for IX Systems. He says, I recently became a FreeBSD ports committer, and I found a project. I founded a project called GhostBSD, and I'm originally from a small city in New Brunswick called Edmundston. So he speaks a very peculiar type of French because he's from New Brunswick, not actually from Quebec, but now lives there.
Okay.
Oh, there's more here. Okay. He says, I was always fascinated by computers and software, and I was hoping to study in computer science at the university. The irony is that I ended up quitting school after I realized that it was 15 years in school and still had 2 years of French grammar courses to complete, and it was the only thing keeping me from going to college and university. He says, I did try to finish a GED, but again, I was still having problems with French grammar, so I just gave up. I did learn that I did not need high school diploma to become a hairdresser or a barber, so I did take some hairdressing courses, finished that, and got a diploma. Then worked as a hairdresser for a short time, but in the meantime, I was trying to get a band together to play music, but that didn't go so well either. And worked at Tim Hortons, so that's a coffee shop here in Canada. And both his first computer, which was a Dell Dimension 1100 for recording music. But after a while, I wanted more than just to be just a cook at a coffee shop. So I applied to Walmart and got a job as an inventory controller. That's where he met his wife. And that's when they moved to Moncton before she was able to start college there and got a transfer to the Walmart there. And he says then he began working for Kent, DC as an order picker. And through the years, I got an inventory controller specialist position. So during his day job, he realized that our warehouse management system was running Rumba, was using VBA scripts for automation. So I started to automate most of his job using those VBA scripts, Excel, and some database reports. Everything coming from email and spreadsheet was almost all automated. And with the VB scripts, I did lots of automation to the point of having scripts making the decision on where products should be placed in the warehouse. I did scripts to make projections on where new products should be placed in the warehouse and so on. And it was at that point that he started to use Python and kind of went from there. And then back in 2017, he got a job opportunity as an automation engineer at IX Systems, and he's been working there in their quality engineering team.
Oh, nice. That's quite of a career already. And so the next question is, how did you become interested in open source?
He says, my first interest in open source started when I wanted to become a hacker. I did try many different GNU Linux distributions, and Ubuntu was the one that he was stuck with for a while. On my journey for searching for new tools, I found a How to Become a Hacker by Eric S. Raymond. Eric's essay was almost coming from the right time in his life, and he started to be more interested in open source and discovered that he was able to learn computer science all by himself instead of having to go to school. So back in 2009, he started GhostBSD as a project to force himself to learn about open source and computer science.
Okay. So when and how did you get interested in the BSD operating systems?
So after he read How to Become a Hacker a couple of times, BSD and BSD Unix were mentioned, and BSD Unix was sticking in his head because it was real Unix. As the essay started, you can find BSD Unix help and resources at bsd.org. From there, FreeBSD was looking promising, so he downloaded FreeBSD, but the fact that once you install it, it doesn't come with a GUI out of the box, I was not really able to get much of a start. But with some searching, he managed to find PCBSD and install PCBSD 1.4. But back then, Eric was a GNOME guy, and PCBSD was KDE. He says, liked Ubuntu a lot and thought, why isn't there a BSD that comes with GNOME too? So that's when he got the idea for GhostBSD.
Okay. And on your Twitter profile, the one for Eric, you state that you're an automation engineer at IX Systems. Can you share what you do in your day-to-day job?
He says, yes, I write Python scripts for testing the REST APIs of FreeNAS with the request and PyTest modules. Maintains the IX automation framework, which installs FreeNAS or TrueOS in Beehive and runs their API tests. I do work on automating for some internal projects as well. I monitor Jenkins to make sure all of our API tests are passing and report any test failures. I sometimes also do manual testing of the API and the user interface, and occasionally work on the web UI automation testing. I also monitor our incremental builds of FreeNAS to ensure that they're passing, and lately I did a lot more time on the TrueView REST and WebSockets API. If you haven't heard of TrueView yet, check out their presentation at VMworld. I also help to reproduce issues and to find the causes using VMs. So when users report a problem, he can try to create that same environment and recreate the problem so it can be fixed. He says he also tests TrueOS installation and upgrades and helped with the TrueOS ports build. And that's probably how we got to this later thing where GhostBSD became a distro on top of TrueOS.
Mm-hmm. Yeah, that leads into the next question. You are the founder and project lead of GhostBSD. Could you describe GhostBSD to those who have never used it or never heard of it?
Yep. So nowadays, GhostBSD is a distro of TrueOS with the Mate desktop. That's the logical continuation of GNOME 2. It is a live system that can be run from a DVD or USB or it can be installed. GhostBSD is developed to perform casual tasks and mostly focused on helping Linux and Windows users become familiar with BSD.
Okay. So developing an operating system is not a small thing. What made you decide to start the GhostBSD project and not join another desktop FreeBSD related project such as PCBSD and desktop BSD at the time?
He says, one word and one word only, KDE. Back all the way back at the beginning in 2009, KDE 3 was ugly, and I was not attracted to any of the projects using Qt and KDE. At the time, I wanted to create a GNOME distro of FreeBSD, and also, as I mentioned before, GhostBSD was a project for me to learn computer science, so I wanted to start learning everything, and what better way than to build a whole operating system? So we went the hard way and started to learn and play things. I was not interested in the beginning material, and it was the same thing for programming. It was difficult at first, but it helped by having multiple people to ask questions.
Oh yeah, certainly. And so how did you get to the name GhostBSD? Did you consider any other names?
At the time, I was working on a personal project to make a transparent computer case. And it was going to be called the Ghost Box, because it would look like a ghost because it was see-through. When I started to work on a live CD version of FreeBSD, my girlfriend, who's now my wife, told me you could just call it GhostBSD or Ghost OS. And that kind of stuck. At first, I thought, he backronym it to GNOME Hacked Operating System Technology on FreeBSD. Just, to show you how bad his English was. But around 2010, it just became GNOME hosted on FreeBSD, and how that spells GhostBSD. The original pronunciation was GhostBSD. It was also the creation of his wife, and she did the GhostBSD logo. The G and host are not the same color, so that you will see that it's a host thing. I wanted to make sure that GhostBSD was nothing to do with ghosts. Today we call it GhostBSD, and GNOME host on FreeBSD is more or less relevant, especially now that it's called Mate. So now he just wants to refer to it as GTK hosted on FreeBSD.
Okay. And so you recently released GhostBSD 18.10. What's new in that version, and what are the key features? And what has changed since GhostBSD 11.1?
So GhostBSD 18.10 is the first one based on TrueOS instead of vanilla FreeBSD, which is a significant change. He's also removed UnionFS because it was causing random hangs when booting and weird memory issues. So the live system is now partially read-write. Joe Maloney, who also works with me at IX Systems, rewrote the whole set of tools that are used to build GhostBSD, and the live system architecture is now a big compressed UZIP file. When booting, it mounts the UZIP file and starts a live session in the chroot. With all these changes, it's made the DVD USB much more stable. Network Manager, not the Linux one, now supports multiple wired and Wi-Fi interfaces. GhostBSD has also come back to its roots by using Mate only. Mate is the same UI as what GNOME 2 was. And GhostBSD started with the GNOME 2 UI. This is about it for significant changes, other than all the things that they would have pulled in from a newer FreeBSD.
Okay, so the current version is 18.10. Will the next version be 19.4, like Ubuntu's version numbering, or is a new version released after the next stable TrueOS release?
He says, I plan to release more often, about every month or two, since we are updating packages so often that we have to publish updated systems. So for significant changes, we're targeting a 19.02.
Oh, okay. So can you tell us something about the development team? Is it yourself, or are there other core team members? I think the interviewer saw 2 other developers on the GitHub project page.
It says right now it's mostly Joe and I, and we are mainly the people behind the development of 18.10. But lately some people did start to get interested in development, including Vester Thacker, Damien Sizderopoulos, sorry, and Ron Georgia. Also, some people are helping in other areas, like Neville Goodard is testing and helping other users on our Telegram and forums, and Vester Thacker is also taking care of our wiki. And Alex Lachov is helping with server administration, and Yetkin Degamarisi is assisting with keeping the website up to date. And hopefully I've not forgotten anybody. We don't really have a list of developers.
Okay. And so how about the relationship with the community? Is it possible for a community member to contribute, and how are those contributions handled?
And lately, most of our community communication has been on Telegram, and it has helped GhostBSD develop a lot compared to using forums and IRC. A lot of users can share their thoughts with us, and it gives us an opportunity to find more help. All the development happens on GitHub, so anyone can contribute by forking and creating a pull request.
Okay. Yep.
I think we're running short on time, so I think we will...
yeah. It's a longer interview.
Yeah, but there's more questions, and if you're interested, you should go check it out.
So, time for the Beastie Bits this week. We found something interesting on Twitter. There's a dialogue-based script to select audio output on FreeBSD.
Yeah, so if you have multiple sound cards and need to pick the right one, it's an interesting script. So please join in our effort to convince the author that that's useful enough that he should create a port.
Yeah, that's the next best thing you would do.
Yes. We shall blow up his mentions.
Yeah. Okay, and we also found that Erlang OTP on OpenBSD is a thing. There's a blog post about it.
Yeah, so this is an OTP client written in Erlang, and it allows you to do your time-based authentication. So just package add Erlang so that you have that, and then make a couple changes to the system here, and then install the client.
Yep. Yeah, that's pretty straightforward. So let's try that out. And someone just can't stop blogging, which is good for us because we can cover it in the show. There's a Capsicum article by Mariusz Zaborski on his blog. And how he uses Capsicum, how he discovered it, and of course the evangelizing that he does. And that's a good introductory part for people getting interested in Capsicum or want to maybe convert a couple of utilities to Capsicum. That's a good starter article.
Yes, Marius has been doing a lot of the good work lately to make it easier to convert applications. So finding common classes of the difficulty you run into when trying to convert an application to Capsicum. There are certain classes of problems you have. Like if the program takes a list of files as input, where there might be literally like 100 files that you're specifying as the input. If in that case, because once you enter the sandbox in Capsicum, you can't access the file system anymore. You can only have files and directories you already opened. But if you're getting a list of paths as the input, then you need to either open every one of those at once at the beginning, and then you have hundreds of files open for no reason, or you don't really have a way to iterate over them. So one of the things he did was a special helper as part of the Casper system in Capsicum, that basically you can take that list and be ready for it, and then basically open them a couple at a time and do what your program is going to do with all those files.
Yeah, and the code example here is using the BS patch that Alan helped convert into a sandboxed version, so that's people can see it at live coding or seeing in the source code how the changes are making it sandboxable or sandboxed.
Yeah, that one was really just a matter of taking all these open commands and putting them higher up in the code before you do cap enter, and then adding the cap enter and the writes. It was actually pretty straightforward.
And there are many more utilities needing of capsicumization, and yeah, that should probably get you started with that blog post. Next up is we have people who want to build more FreeBSD on Raspberry Pi 3s. They can do that with Crochet, I guess that's the name.
Yep, and Pooter.
Yeah, so package building on the little Raspberry Pi credit card size shape. That is possible. It takes some time. Be aware of that, but Crochet can make it a bit more easier to manage those packages.
Mm-hmm.
Okay,
so if you want to do that, check that out. Yep. This next one is interesting. Over at the NetBSD blog, they have introducing the micro UBSAN. So instead of UBSAN, you have UUBSAN, but it's the micro U, the special one. Anyway, so with micro UBSAN, it's a clean room reimplementation of the undefined behavior runtime. So sanitization is a process of detecting potential issues during the execution of a process. Sanitization instruments or embedded checks within the general code or generated code and interact with the runtime linked into the executable, either statically or dynamically. Over the past month, I've finished a functional support for MK Sanitizer with address sanitizer and undefined behavior sanitizer. The MK Sanitizer uses the default compiler runtime shipped with Clang and GCC and has been ported to NetBSD. However, over that time, I've implemented from scratch a clean room version of the UBSAN runtime. The initial motivation was the need for developing one for the purpose of catching undefined behavior reports, unspecified code semantics in a compiled executable in the NetBSD kernel. However, since we need to write a new runtime, I've decided to go 2 steps further and design code that will be usable inside libc and as a standard library, like linked C files together, and use our existing ATF regression test framework.
Ooh, great.
So if you're interested in that, check that out. That sounds very interesting.
Mm-hmm.
And if you have some time back, we reminded you about Package Source Con, which was back in July in Berlin. But the videos are up now. So if you want to see what you missed, check it out.
That's exactly the material for the cold winter nights that are coming and you don't know what to watch. Definitely check that out. And last but not least, we have an article from the FreeBSD folks that are porting the DRM stuff, among other things, the graphics parts to FreeBSD, and they posted a blog post about getting started with DRM-Kmod. That's a nice overview article.
They explain which one you want to use and how to do it and how easy it is. So how to check if your system has a graphics driver that'll be supported or a graphics hardware that will be supported. How to install the package. It's just literally package install DRM-Kmod. Follow the instructions in the post install bit for depending which CPU or which graphics card you have, load the correct driver. Make sure your user is part of the video group so that you'll have access to the device, and then you're good to go.
Yeah, Niklas mentioned to me that they recently, or basically today, updated the DRM driver for FreeBSD 11.2 and 12.0. So 11.2 is now comparable to 4.11, and 12.0 is 4.16. Which includes very experimental support for i386, but people who are interested and should check it out. And if you're into graphics and can help out, then definitely get in touch with them. Every support and help is appreciated.
Yeah.
Okay. Now, let's go into feedback and questions. It's getting dry in our inboxes. We could use a couple of more emails and questions, be it short or small, something maybe about the new FreeBSD system or anything that you encountered. That would make a good part for this feedback and questions section here. Send all of these things to feedback@bsdnow.tv. But this week we have Malcolm as the first question asker, I guess. Show segment idea, short and sweet, asking or telling us that while listening to a recent show, I got an idea for a recurring segment for the show. I don't know how much work it would be, but perhaps each week it would be worth pointing out a ticket that is a good candidate for someone interested in contributing. Could be documentation, or maybe fixing the known silly bug, or adding the nprox command, etc. Maybe it's support, yada yada. Thanks for the great show.
Yeah. The one downside is if we do find a PR and we get 8 people trying to work on it, only one of them is going to finish it. But yeah, that wouldn't be a bad idea. And we just pick a couple that could use some attention. We have lots of docs ones if you want to work on documentation.
Oh, yeah.
Like there's just a pending one to just add some links to the mandoc documentation to the FreeBSD documentation primer section on man pages. Or, I found a couple of just typos in man pages that I haven't had time to fix and, read the whole man page and make sure all of it is right, not just the one typo I happen to notice and so on.
Yeah, these are very low-hanging fruits, and if that gets you interested more and more, then we can definitely give you more work. And people just look at the PRs and say, hey, I could do that stuff. It's not difficult. And I have some free time for that. So that's either it's whether it's FreeBSD or OpenBSD or NetBSD, whatever BSD you're using, they certainly can make use of help in their bug databases. Okay, yeah, that's a good thing here. Or if you get bored over the holidays, maybe then you can squash some bugs here. Okay, next up is Fraser with a question. About FreeBSD official binary package options. That's an interesting thing now that the 12.0 release is out. Goes like this. Hi, Benedict and Ellen, BSD Now listeners since episode 001. Excellent. First time question asker, although you once featured a story about my number plate, episode 88. Oh, that was before my time with Chris. Okay, well, that's dedication, certainly. Cool. Putreer is a great tool, he writes, for building custom package sets with different options. But sometimes I feel that the options in the official packages could be better. For example, yesterday I needed a build of graphics/Blender with Collada import/export support. It took Putreer a long time, about 8 hours, to build that package repo. Surely I'm not the only person to need this option. So my question, for the official package repos, or rather the Putreer configuration that builds them, where is the configuration for different port options stored? How can we request changes to the options used for some port?
So the default set of options are basically defined in the make file in the ports tree. And
make config.
Well, no,
or make
config is what does it, but you'd have to read the source code of the make file to actually see what the default for each option is, and that's where you would change I think it's yes to, or no to yes, or whatever, to enable an option by default.
There's make show config to just display what the current options are.
Sure, but that's not quite the same thing. But yes, Nicholas in the chat room points out in the make file, there's a line options_default, and it will have the list of default options, and you would just add the extra option that you want to have as the default. Remember that sometimes there's a reason it's not on by default. Sometimes that can be licensing or something, like why we don't have certain things enabled. In this one, likely it can just be turned on. If you're installing Blender, you're probably okay with it being a little bit bigger with this extra support. And I'm guessing it's not that big of a deal. But sometimes an option is turned off because, it would suck in like 4 other dependencies and make things more complicated. But I think in most cases, yes, we should default to more of these things being, the default package being more useful and avoid having to have people build it all the time. So yes, look in the make file, find the diff, you can make a patch and post it to Fabricator, and we can get that integrated into FreeBSD.
Okay, yeah. Or reach out to the maintainer. They are certainly interested in what options people are using most. Okay, definitely something people should consider. And next up is, or last but not least, is Harry about the BSD magazine. Writing that, hi, I've been waiting for a new BSD magazine issue for a while and sadly heard a rumor that publication is on suspended state. Maybe you have some inside information about the case you could share with our listeners. And of course, thank you for keeping the podcast going. Show must go on. Yeah. I have no information about them. I look occasionally if there's a new issue out, but they haven't published. Maybe they're in some kind of creative pause to restart the thing.
BSD Mag is shut down.
Oh, completely?
Yeah. So,
okay.
Well, read the FreeBSD journal. It's better anyway.
Yes, there will be an issue coming out, I think, for December, if we can make it. Otherwise, it will be in early January with some interesting articles in there. and yeah, that should be some kind of replacement. It's not a complete replacement, but still something for you to read on a long drive or commute or something. Oh yeah, but it's good to have that information so that people don't just wait for the next issue to come out. So yeah, nice show, and yeah, thanks everyone for listening. That wraps up our week's episode, and yeah, see you next week where we do our last episode for this year, if I'm not mistaken. But we will tell you in next week's episode. And
there'll be a show every week. It's just, yes, I think the
there's a show.
Boxing Day, the day after Christmas show will be pre-recorded.
Yeah, so you see us in conserved form. But we'll be there in January again for you, and yeah, we'll have something for you next week always. Okay, thanks, and yeah, keep in touch.